In the last lecture, we began a discussion on the impact of aerosols on climate. And we mentioned that in comparison to carbon dioxide, the impact of aerosols is not so easy to model. This is because aerosols are not uniformly present everywhere in the earth. The aerosols released by human activities, they are confined to land and mostly urban areas. In contrast, the carbon dioxide that is released by human activities over land mixes uniformly all over the world, because it is a gas which does not react and it has a long lifetime. So, it has time to spread all over the world, all the way to the poles, so that the amount of carbon dioxide in parts per million is almost same everywhere. Okay? Aerosols are very different. They are not gases, they are particles, and their lifetime in the atmosphere is of the order of days to weeks, and so they are very high only in the region where they are released, and then they decay very quickly. So, the first problem is, for you to estimate the impact of aerosols on Earth's climate, you need to know the complete data on aerosol concentrations all over the world, okay, both over land and ocean. Then you have to average over all that and calculate the impact of those aerosols on the solar radiation absorbed or reflected. Okay. So, for a long time we did not even have a good data. So, after people realized the importance of aerosols on climate, most countries have taken up detailed measurement of aerosols at various cities and other areas over the last 20 years. So, we have good data now, which we discussed. We showed the number of stations in India which measure aerosols. The second problem is the aerosols are not one chemical composition. Carbon dioxide is CO2, it does not react, it does not change, it remains the same as long as it is in the atmosphere. But aerosol come in variety of forms, the one which are released by human activities. There are the sulfate aerosols which come from sulfur dioxide, there are the black carbon aerosols due to incomplete combustion, what we call soot, and there is organic carbon and a couple other aerosols are there. So, you need to know the amount of aerosols in a given region and the various types. Is it sulfate or is it black carbon? For example, at present in the developed world, the black carbon emission is very small, okay? It is mostly sulfate, even that is coming down. On the other hand, in developing regions like India and China, there is a lot of emission of black carbon due to incomplete combustion while cooking. When you use firewood or coal, you release a lot of soot in the atmosphere. Okay? So, you need to know the relative amount of sulfate and black carbon in different parts of the world, they are not same. So, this has made an accurate estimate of the impact of aerosol on the global climate very difficult, okay? Because the sulfate aerosols reflect the radiation from the sun, so cool the earth, partly compensating for the warming caused by carbon dioxide due to greenhouse effect. But black carbon heats the atmosphere by absorbing sun's radiation and hence adds on to the warming caused by carbon dioxide. So, while these issues are being debated, when the Kyoto Protocol was signed, if you remember, Kyoto Protocol was signed in 1997, okay, almost 37 years ago, and 27 years ago, I am sorry, and this protocol was signed by almost all the countries in the world except a few. United States signed the protocol and it was involved in the negotiation, but after that the government changed in United States and the new government decided that they will not ratify the Kyoto Protocol. They signed it, but they did not ratify, because the only red color in this whole figure is United States along with Alaska. There is the only country which has signed the protocol but not ratified it, because there are few countries which did not even sign. Okay, they are very small countries. So, this became a major issue, and what is the reason given by United States for not signing or ratifying the Kyoto Protocol? President George W. Bush, who took over on January 2001, said the Kyoto Protocol failed to address two major pollutants. One is soot, other is ozone. He was completely wrong. This was an excuse not to ratify the Kyoto Protocol. Now, because of this, for a long time an impression was given that the global warming caused by black carbon is as high as that caused by carbon dioxide. This is not true at all. All the work done in the last 25 years has shown that the warming caused by carbon dioxide dominates the global mean temperature. Black carbon has a very minor role to play. Okay. But this was the excuse used by United States not to ratify the Kyoto Protocol, and it led to a lot of confusion. And I mentioned in the last lecture, they decided to put methane and black carbon under the so called short lived climate forces. That is, those emissions which cause warming in the short term, but not in the long term. Okay? Because CO2 has an impact on a very long term, 100 years, 200 years and so on, while methane, aerosols have a very short term impact. But methane and aerosols are not similar. Methane has a lifetime of 10 to 20 years, while black carbon and sulfate aerosol have a lifetime of weeks. You cannot compare aerosols to methane, but it was put together in one category, and some of the things I showed in the last lecture, they put them same category, although it is completely scientifically inappropriate. Okay. Now, with the United States not ratifying Kyoto Protocol, all kinds of data was given to indicate that by this reducing black carbon, we may bring down the global warming rapidly. Okay. Two examples are given here of two papers published in 2009, one in Nature Geoscience, a well known journal, that a drastic reduction in black carbon could provide immediate relief. This is completely wrong. There is no basis for it. All the work done subsequently in the next 15 years show that the role of black carbon is very minor. Okay. And here are some papers, and the reason why it is very simple. You look at the satellite measure aerosol radiative forcing, that is the impact aerosol has at the top of the atmosphere in watts per meter square, so that we can compare it with carbon dioxide. You see that we focus on clear sky, where our understanding is very good. Cloudy sky is more complicated. In clear sky, sulfate causes a cooling of minus 0.28 watts per meter squared, while black carbon causes a warming of 0.11. I am sorry, let's look at sulphate. Sulphate causes a cooling of minus 0.39. Black carbon causes a warming of 0.11, which is about less than a third. If you combine those two, you get total of minus 0.28. Okay. So, the cooling by sulphate still dominates over warming by black carbon, and black carbon impact is much smaller than that of sulphate. So, it is very clear based on various couple models, about 14 of them, along with satellite data, that the warming due to black carbon is much smaller than the cooling by sulphate. And remember that in many industrial processes, incomplete combustion releases both sulphate aerosol and black carbon aerosols. So, when you try to reduce the emission of aerosols, you will reduce both, okay, except for cooking by firewood, which is a separate entity. Okay. So, the point to be remembered is that when you come to cloudy sky, it is even more dramatic. The warming caused by black carbon is 0.06, while that caused by sulphate is minus 0.78, okay, almost 13 times larger cooling by sulphate. So, quite clearly the impression given by the United States government that black carbon emission is very, very important is not valid. Now, these aerosols which have been released over the last 50 years, of course, cause a reduction in radiation coming to the surface. That is why they cause cooling. And the reduction in terms of how much is called dimming is over 10% in the United States, where there are strict air pollution control laws, but much higher over Russia, the former Soviet Union, over China, over India. In all these countries, air pollution control had not taken place between 1991 and 2001, and hence there is much more dimming. Okay. So, remember that the impact of aerosol is highly local. The reduction radiation over US is only 10%, while over India is 33%. So, when you look at aerosol, the global mean is not as relevant as local conditions. Now, to show what will happen in the next 50 years as we try to reduce the greenhouse gases as per the agreement in Paris, what will happen is, as the greenhouse gases are reduced, the warming caused by greenhouse gases will come down. Okay. So, will the cooling caused by sulphate aerosol. The cooling caused by sulphate aerosol will have an immediate impact, because its lifetime is only weeks, while the warming caused by carbon dioxide, its impact will not be seen for 30, 40, 50 years. That is why here in this result they are comparing the surface air temperature at 2100 relative to 2020 on account of the reduction of greenhouse gas emission. You find that the warming due to aerosol dominates the blue curve, okay, all over the world. Okay. Every part of the world is covered here. In all of them, the warming caused by aerosol causing warming because the greenhouse gases were removed, and the major aerosol is sulphate, which used to cause cooling, and the impact of sulphate is seen immediately, very next week. You remove sulphate today, next week you will see a warming. Well, the greenhouse gas impact will be seen after 50 years. That is why this paper by Wang in Nature Communication in 2023 clearly point out that all parts of the world will see a warming of the order of 1 to 1.5 degrees because of the reduction in greenhouse gases. Okay. Both greenhouse gases and sulfate aerosols are going to reduce. The impact of sulfate is immediate, impact of greenhouse gas is more of a long term. Okay. So, aerosols overtake greenhouse gases to cause warming and also extreme weather. So, another paper published 10 years ago said, although the effects of greenhouse gas and volcanic forces are robust across models specifications, we cannot detect the effect of black carbon. So, the bogey of black carbon that was created by United States has been shown to be completely irrelevant. Okay. It hardly seen any impact in this one. So, another paper says that we find that the maximum 21st century warming is largely unaffected by additional black carbon related measures, because the key emission sources are already phased out during CO2 mitigation scenarios. Okay. So, when you mitigate CO2, you also mitigate black carbon, reduce it, and so its impact is not seen as much as CO2, because CO2 is the dominant factor in global warming. So, the results of course depend on how rapidly black carbon is reduced compared to sulfur dioxide. Okay. Sulfur dioxide causes cooling, carbon dioxide causes warming, but I wanted to see the difference. The peak in black carbon emissions are around 8 teragram per year, while the peak in sulfate is 140 teragram per year. So, sulfate dominates over black carbon by a factor of 10 or more. So, the reduction in sulfate will see much more impact than the reduction in black carbon. Okay. That is why when you remove sulfate, and it is already going on, the cooling due to sulfate is gone, and so you will see a lot of warming caused by greenhouse gases. So, that is why even in 2009 a paper published in Science said clean the air and heat the planet. If you clean the air to reduce air pollution, which we must do because it causes about 1 million deaths in India on account of inhaling these aerosols. If you do that, air pollution control will accelerate global warming. But there is not much choice. In most countries, air pollution control will happen because it has immediate improvement on our health, but it will cause a long term warming, which is unavoidable. Okay. Unless we bring down the carbon dioxide emission more rapidly. Okay. So, this is in the coming decades. As you go further, it may not be as bad. So, this point is also made in a recent paper in Nature by Prasad in November 2022, showing that both black carbon and sulfur dioxide are being reduced, but sulfur dioxide reduction started in 1970s because of strict air pollution control laws in Europe and United States. So, they already come down rapidly by a factor of 2 in 50 years, while in the case of black carbon, which is primarily released by the developing world, the reduction is still pretty slow, and in some cases it may even increase. Okay. So, there is a big difference between sulfate aerosol and black carbon aerosol in terms of air pollution control laws, because in rich countries the major emission was sulfate, and they enforced strict laws to bring it down. In the developing world like China and India, black carbon was a dominant emission, and that has not yet been completely controlled. It will take another 30-40 years. So, the impact of sulphate will be seen first, the impact of black carbon may be seen somewhat later. Okay? And this is brought out by the paper by Bressour and Rockner, published almost 20 years ago. They show that if you improve air quality, the global mean temperature will rise by almost 1 degree centigrade between now and 2050. Okay? And so will the global mean rainfall. Okay? Because the temperature goes up, the humidity goes up, and that increases rainfall. But our concern should be this rapid warming will occur in the next few decades because of measures related to air quality. Okay? So, this is an unavoidable consequence because of the different lifetime of aerosol versus CO2. Aerosol lifetime of weeks, CO2 is lifetime of hundreds of years. The impact of two will occur in two different time scales. If we reduce CO2 from today, we will see the benefit 50 to 100 years later. If we reduce sulfur dioxide emission today, we will see its impact in terms of warming immediately. Okay? That is the point I want you to understand. Now, this is again shown by a recent paper in Nature Communications published last year, that the present day aerosol optical depth, a measure of total aerosol in the column as measured by satellites, is quite high in India, China, Africa and South America. But by 2050, these countries will start reducing the sulfur dioxide emissions. So, the aerosol optical depth will come down substantially, and hence global warming will accelerate. Okay? That is the point Wang has made, and so this is the point which has to be dealt with, which is rather complicated, that we want the global warming to be mitigated in the next 20 years. It will not happen because of sulfate aerosol. Okay? In addition, remember that there are so many other chemicals we are releasing into the atmosphere over the last 40 years. Most of them are greenhouse gases, they have an impact. Okay? And they have a long lifetime, like carbon dioxide. And so, they will also have some impact which is unavoidable. Now, as regard to aerosol, even now there is no agreement on the indirect impact of aerosols, that is the impact due to the way aerosol alters clouds. Okay? So, for example, in the paper published by Tosca and others, they say the absence of an interactive cloud microphysical response, that is the response of liquid droplets on ice, introduces limitations to analysis. Okay? And most studies show that there is a reduction in rainfall because of the aerosol indirect effect, that is aerosols affecting clouds. Another paper says deep convection aerosol indirect effect will invigorate updrafts, that is make it more vigorous and increase rainfall. That is only for deep convection, that is clouds which go from surface to about 10 kilometers. The other studies are related to shallow clouds which change in a different way than the deep clouds. Now, let us look at the aerosol effective radiative forcing as documented in the IPCC report published in 2007, comparison to the more recent one. IPCC calculated force up to 2005 because they released a report in 2007, while the most recent one, AR6, calculated the forcing of 2019. Therefore, you can see CO2 forcing has gone up in those 14 years. Aerosol effect is not that different. Okay. So, the net forcing by human activities was 1.5 in 2005, it is now 2.7. So, this increase of 1.1 is mainly due to carbon dioxide and methane. Okay. So, notice that the total aerosol effect shown here is this is little higher than here because there is much more time to be accounted for. But the main thing is that the net anthropogenic forcing has gone to 1.6 to 2.7, and the uncertainty in that forcing, the large variation in our estimate here is about 1.5 watts a meter squared, while here also it was around the same value, a little more actually. So, we still have to deal with 2.7 watts a meter squared of human induced forcing, even after accounting for the cooling by sulfate aerosol. Now, this is where the problem comes in. You see that we have fairly accurate estimate of the radiating forcing by greenhouse gases. There is a very small spread here, okay, due to CO2, ozone and other gases, while aerosol has a huge spread, okay, all the way from -3 to all the way to 0. Okay. And so, you have to combine these two, aerosol and greenhouse gases. So, the net anthropogenic radiative forcing now is highly uncertain compared to only greenhouse gases, and notice it is skewed to one side. Okay. On this side there is more than on this side because of the aerosol uncertainty. Okay. This is what causes a large uncertainty in our ability to predict how much global warming will occur. Notice that this ultimately is less than this is around -1, this is 3. But because we do not know is -1 or -2, there is a large uncertainty in the future warming. And on top of that, when we reduce the air pollution, this will go out, this aerosol forcing. Then the warming will go up much high, and our ability to predict the warming also will become very high. To highlight this, I am showing from various models what is the global warming over the last 160 years if you do not include aerosol and if you include aerosol. You can see there is a huge difference here. Without aerosol, we would have got by now around 2° warming. We are only around 1.5 now. Okay. So, we are lucky because of the cooling caused by aerosol, okay, which is of the order of 0.75 watts a meter squared. Okay. There is one more simulation in the 6th assessment, latest one. So, if you look at around 2020, they are saying that without aerosol we would have had 2° warming from 14 to 16, but because of that we have 1.5 warming, which we saw last year. 2023 had a warming of 1.5 degrees centigrade, and that is what, when you combine greenhouse gas and aerosol, that is what you get. Okay. If it did not have these emissions by human beings, you would have had almost no change. This is due to natural process only. So, you can see clearly that the 1.5 degree warming you have seen today around 2023 is mainly on account of greenhouse gases, partly mitigated by sulfate aerosol. Okay. But in a regional scenario, things are quite different. In India, if you look at the winter temperature, winter maximum temperature between 1951 and 2010, which is a 60-year period, you see that most of South India there is warming of the order of 0.02 degree per year or 2 degrees in 100 years, which is what we expect due to greenhouse gases. But over the Indo-Gangetic plain, which is highly polluted in winter, all of you know that, you see a cooling of 1 degree in 100 years. So, I want you to see the huge impact of aerosol. There is a difference between South India and the Indo-Gangetic plain, because air pollution in the Indo-Gangetic plain in winter is very, very high, and that is clearly shown by the satellite data showing a huge layer of pollutants on top of the cloud, and this pollutant reduces warming due to greenhouse gases. Okay. So, India is a place where we clearly see locally the change in sign. South India there is warming, North India there is cooling. Okay. Now, last year we had a world record of 1.5 degree warming of the temperature. Of course, this is here showing compared to 2020, which is only 1 degree, but you compare it to the 19th century, it was 1.5, and the major question was, why was it so high, that warming last year? Okay. There are various reasons, and many parts of the world saw this huge warming which caused heat waves, and United Nations warned about this problem. And one of the reasons, interesting reason, is due to the fact that clouds had changed in 2023. That is because the body which controls emission by ships globally, it cannot be controlled in various countries. It is a maritime shipping authority, which had passed a law in 2020 to cut down the emission of soot by and sulfate by these ships, and it was enforced in the last few years, and the impact of that is seen, and these ships mainly are transporting goods to the developed world from China. That is a major path, and when the International Maritime Organization enforces law, the sulfate emissions suddenly dropped around 2020 onwards, okay, from around 12 megatons 10 years ago to almost 2 megatons. Okay. So, this paper which science journal showed that had an impact on global mean temperature. Okay. Yeah. So, we will conclude the lecture today, and I will continue this discussion in the next lecture, showing talking about the impact of aerosols. Thank you.